Hey everybody, this is Jeff, and this is PCC's CS161A, Module 1. One of the things I want to cover here in this module is talking about the algorithmic planning document and how you might fill that out as we work our way through this class. Those of you that have taken CS160, this looks familiar, and it is a same document actually, but we're going to continue to get more and more precise as we write more and more complicated programs. So to do that, we're going to kind of look at, in module 1 here, what we're going to do here. There's a discussion where each of you are going to create an algorithm, and you're going to use the algorithmic planning document. So here is the template for that. I'm going to make a copy of that. That's what you'll do too. You'll make a copy, and then of course you can save it as a PDF. And store it in your area. But we're going to basically follow this. I'm going to we're not going to write a program in this case. We're going to pretend we will. So this program will multiply two-digit numbers using the long multiplication approach. For those of you that don't remember what a long multiplication approach is, I'll demonstrate it. It's how I and many of you, if not all of you, learned how to multiply numbers together. We'll go through that with an example here. You're going to so one thing that I've seen students do in CS160 more than 161 is they'll write their description, and then they'll write their description in the sample run. The sample run is supposed to show you what the output will look like, right? So it might be something like this. Enter the first number, enter the second number, and the x-axis are just showing placeholders for what the user will do. And so let's make this some real numbers here. We're going to multiply, let's see, 31 by 11 as an example. Okay, so now we'll use my actual example, 42 times 86. And instead of doing it in this table here, this hard to format it here, what I'm going to do is I'm going to show you the rest of it in a Microsoft Excel sheet, and then I can transpose it here later on here. Before we do that, let's talk about our inputs. So our inputs are two-digit integers. So these are between 0 and 99 inclusive. And we'll call these A and B. The output is a 4-digit integer. 0 to 9801, I think, is the maximum. 99 times 99. I will call this X. Okay. And then for my calculations, I need to do integer multiplication, single digits, and then addition, 1 to 4 digits. Okay. So we'll come back to the logic. We'll come back to the sample run here. Before I do that, though, let me show you one more thing here. Also in this discussion one, there's a sample document. The sample document is another example of an algorithm braiding hair, and so it's a little bit more abstract, right? And you can read this on your own, but I can't demonstrate this obviously with my head. But it kind of talks about what the different steps are in the input and the output. It's just more abstract, right? And I think for your discussion one, I would encourage you to pick something as abstract as you want or as detailed as you want, but keep it simple, right? A lot of students like to talk about a recipe, cooking or baking. Some students will talk about part of their commute. Well, I got to go and get on this light rail station, and then I got to go do this and cross the street and things like that, right? Any of those are good examples. You can pick something you picked in CS160 as well, converting Celsius to Fahrenheit and Kelvin, and could do that kind of stuff too. I just encourage you to, stretch yourself a little bit, not just take the algorithm you used you know, in CS160 and just paste it in, right? So now let's go back to mine. And here's the example I'm going to demonstrate. I'm going to do a long multiplication of 42 times 86. These four columns are your thousandth column, your thousands, your hundreds, your tens, and your ones. That's what this shows up here. Okay, so I'm just going to kind of show things as they come on board each step by step here. Step one is we're going to multiply the top operand, right? So I can actually do this here. This is the top operand, and this is the bottom operand. You know, we called this A, and we called this guy B in my sample, in my document, right? So we're going to multiply the top operand by the ones digit of the second operand, but I say that this is a third part step here. So the first of those three steps is I multiply the two ones digits together, right? And I get 6 times 2, which is 12, and I put that result there, right? My second step is I'm going to multiply the tens digit, which is the 4 multiplied by the 6, but I'm going to place that result in the tens column. So 4 times 6 is 24 placed in the tens column. And then as the third step is I place a 0 in the ones digit of that step B's result, right? So I just place a 0 there. The 0 is implied here, right? For all of you that know how to do this, right? But again, we have to be specific as much as possible when we're designing these algorithms. Okay, I am going to hide some of this just so that I can keep this all on the screen. And now we're going to start with the next step. Oops, I hid too early. Unhide. We need to take this and add them together. And so this is I lied, it's a 4-part step. So we now have 12 plus 240, and that's equal to 252. So that's the result of the 42 times 6. All right, now we're going to start a step 2. And we're going to multiply the top operand by the tens digit of the second operand. This is like a 6-part step. I think it's either 5 or 6. Let's see. Okay, so we start with we multiply the ones digit of the top operand by the tens digit of the bottom operand, placing the result in the tens column. So 8 times 2 is 16, so we place that there. Okay. Now we're going to add a 0, right, which is implied here as step 2. I'm going to hide this. Okay. Step 3, or C here, is we're now going to multiply the tens digit by the second operand times the tens digit of the first operand. So that's 4 times 8, and place that result in the hundredths column. And so we get 32 there. Okay, and you're probably guessing that the next step here is to fill the zeros out in both the tens and the hundredths column here. Okay, and then we add these together. And so that's a 5-part step. So 160 plus 3,200 is 33,360. Okay, let's see what our next step is here. Now we're going to add the results of step 1 and step 2 together. And so result of step 1 is just this, right? It's not really another step. I'm just bringing that same number down, right? Result of step 2 is this number, just bringing this down. So now we can hide all this. Okay. And we add these guys together. 252 plus 3,360 is 3,612. And because I'm inside Excel, I might as well just double check that. 42 times 26 is 3,612. Okay, so there's your example here. I will post this spreadsheet with the video if you want to go through this. It's a lot of detail demonstrating what your program has to do, right? If you're going to actually, like if your programming language didn't know how to multiply integers together and all it knew how to do was your multiplication tables that we all learned early on, and you had to write this, you got to get to this level of detail, right? Okay, so what I would do here then in step D is I would go back and I would unhide. I would go back and walk through all of these, right? So for example, I would say multiply the ones digit of A with the ones, that's not possessive, is it? I don't think it is. Ones digits with the one digit of B. That, step one, and so on, right? And so you could write that out into that level of detail. The flow chart in this case is super simple. There's no decision making, right? It's just go through each of these steps and do the additions in each of these steps. All right, so this should arm you with enough information to do your discussion one. Let's take a look at assignment 1. I think I had it up already, but we're going to look at it anyway. All right, assignment 1 is a pizza party algorithm. Okay, so you're going to read through some of this. And again, for assignment 1, you're not writing a program for this. You're doing pseudocode and a flowchart. Okay, talk about the task here and some details. Actually, this is important right here. I skipped over this, right? You got some sample information to look at. You must, the customer is going to enter the number of people. The algorithm needs to compute the number of pizzas. We don't sell parts of pizzas. We only sell whole pizzas, so you have to round up here. And there's some assumptions here. Okay, so this is what you'll do for assignment 1. And there's some additional support here. In addition to this video, obviously, some stuff that's probably better helpful here. So that should arm you for assignment 1 and that discussion. As always, post questions to the discussion board, and looking forward to seeing your algorithm ideas and your assignment.